Okay, yes. Good morning. Hi, Lauren. You asked for a few examples from Worksheet 3, so I'll go down through some of those now. This is a really good one to get examples for, I think, because it's a very fundamental. I've said that a bunch, I know, for these activities, but the whole unit is. But this one especially is a type of sort of algebra operation that you're going to see a whole bunch. So I will go down and I'll do two or three examples off this sheet. I think once I show you a few, it'll start becoming fairly clear how this works. This is going to be math 1101A unit 3 again, and this is worksheet 3. Yeah, let's keep a rule of threes here, right? Let's do three examples after this one maybe. I'll do number one first, like it shows up there in the corner. So here we have two binomials, right? A binomial is sort of a section of math that has a section of an equation or a section of an expression that has two terms. So x minus 14, this is two terms because anything separated by a plus or a minus is a different term, right? So x is a term, the negative 14 is a term. This x is a term, and this positive 9 is a term. So when we multiply these together, we're going to use a thing that we call FOIL. That's the method, that's the name that we call it. And it stands for first, outer, inner, and last. Okay, so let me just move that down. You'll see it more clearly there in a bit when, I'll send you this when I'm done, same as always. Right, so don't worry too much about it being blocked by the expand and simplify in the corner. Right, but FOIL means first, outer, inner, last, and that's the rule that we'll keep in mind whenever we're doing binomial multiplication. It's very similar for trinomials and other polynomials. You'll see that in time, but once you learn the basics, it'll all be fairly straightforward. So just to show you what the FOIL means, tell you what, I'll write this part in red. Maybe I'll have that be the convention throughout throughout these examples. So the FOIL part will be kind of color coded for you. But one way that we represent this is by drawing lines over the top of it. Now this step is one you wouldn't necessarily need to write out, but I'm just showing you that when we do first, it's going to be these two multiplied together. So that's our first, because it's the first term of both the binomials. Then outer, outer means the two on the outside. So the second two that we multiply are going to be those two, like that. Those are the outer. Then we're going to do the inner. Inner is going to be these two, like so. And then last is going to be the last one of this and the last one of this. So you see the way the lines end up. What we're doing is we're just multiplying every possible combination, right? There's the first term here multiplied by the first here, first by the second, second by the first, and second by the second. It's because when we multiply these together, each term here multiplies by each term here. So when we have two numbers multiplied by two numbers, we end up with four numbers. Right? And this is the kind of thing that you would see later on, say in matrix multiplication. You could see them sort of written out visually. It would look a little bit like a Punnett square. I don't know if you're familiar with that. I don't believe you've done the biology courses here with us yet. But yeah, I mean, we can visualize this as a matrix, and later on, we don't actually get into that kind of math in this section, but it's the sort of math that you would get into if you went and did more math at another college or university or something in a program beyond ABE. You would get into matrix multiplication in like a linear algebra course or whatever. But anyway, I'm going to go ahead and multiply these guys out. So we're going to have x times x is going to be our first one, right? If we have an x multiplied by an x. Tell you what. I'm going to do another one in red here because this is one that you won't often multiply out, or write out rather. So first we'll have an x times an x, and that'll be our first term. Then we're going to have plus x times 9. That's going to be our second one because it's going to be a representation of the outer. Then the inner is going to be a negative 14 times x, and then we're going to have a negative 14 times 9. Now, to be very, very, very precise here, what I could do is I could call this positive and call this a negative 14 and call this a plus and call this a negative 14. That's technically really what we're doing. So that this is a good thing to keep in mind, that you could consider it as always being a plus, but these are negatives. It won't have affected a ton, but you'll see what it comes out to be. Now this blue one is more what you would write down from here, right? So x times x is going to be x squared. 9 times x is going to be 9x. Negative 14 times x is going to be a minus 14x. And negative 14 times 9 is going to be 140 minus 9, 126. So that'd be a negative 126. Anything times 9, right, is the same as that thing times 10 minus one of them. Anyway, mental math. So I always mention that kind of stuff. And now it says expand and simplify. You see up there in the corner. So the and simplify part just means when we get to this point, we have to go ahead and combine our like terms. So plus 9 minus 14 is going to give us a minus 5. It's going to be x squared minus 5x minus 126. Easy, right? Nothing to it. So let's scroll down. Let's pick another one. Pick one that's maybe a small bit different. Yeah, here we go. Question 7. I want to make sure that I'm covering some of the edge cases, like some of the different types of things that they're going to show you. Let's go ahead and do number 7. Do that one in green over here. We've got 8x plus 9 multiplied by 7 minus 6x. And look at that. Here, usually the x's will be in the first. Over here, the x is in the second spot. Does that matter? Not at all. Not a tiny bit. Doesn't matter at all. One iota. This again to show you what it will look like with FOIL. And again, right, this is not something that you would necessarily need to write out. But I'm going to keep doing it here just to keep showing you how these work. So our first is going to be those two. Our outer is going to be those two, like that. Our inner is going to be those two, and our last is going to be those. Sort of blend the lines together there, but you'll see here now in a second. So it's going to be 8x times 7. Actually, you know what? I'll keep doing the same thing I did over here, and I'll keep the same convention of having the red words be stuff that you wouldn't always write out, but it's going to be 8x times 7, right? And then it's going to be plus 8x times negative 6x. We had to keep the signs there. Plus 9 times 7 for those two. Plus 9 times negative 6x. They're like so. Then, the way we would often write it is we would go from this step straight to this one here. So 8 times 7 is going to be 56x. It's going to be plus 8x times negative 6x. Now 8 times 6 is 48, but this is negative. This is going to be a minus 48x squared, because there's an x here and an x here. 9 times 7 is, of course, 63. This last one, 9 times negative 6x, is going to be a negative 54x. Now, we're not quite done. There are two conventions that we can use here to simplify. One is, of course, positive 56x minus 54x. It's going to leave you with 2x, right? But then we will generally put them in descending order of power. Notice over here I had an x squared first, then a single x, and then no x's at all. That's not like a hard and fast rule, but it is a convention. And we will do that as part of our simplifying. So I will call this a negative 48x squared plus 2x plus 63. Right? Because this one just got moved to the first part. This one has positive 56x, subtract 54x, leaving us with 2x's. And this one over here is going to be a 63. All right, so let's do maybe one other one. Yeah. All right, sure. I'll do 10. Just to gain, right, to show some of the edge cases or the different ways it'll be written. I'll do 10 in black down here. This will be 4x plus 9 squared. Now, of course, you know that the symbol squared means that it's just the thing multiplied by itself. So all that's going to do is expand to just the same thing written down twice multiplied together, right? Easy. And then from here, very, very similar to the first two questions, right? So the FOIL, first, outer, inner, last, like so. You don't need to draw this sort of thing. I'm just doing it, to really over-explain what I'm doing here so that it makes perfect sense to you, or so that you've got a lot of resources that you can go back and check to make sure that you're doing it correctly. So then we're going to end up with 4x times 4x for the first one. Then we're going to have plus 4x times 9 for the second one, plus 9 times 4x for the third one, plus 9 times 9 for the final one. Okay. 16x squared plus 36x plus another 36x, because of course 4x times 9 and 9 times 4x are the same, right? Because multiplication is commutative, meaning the order doesn't matter. Now I'm just going to go through and group the two of them together. There we go. That's all there is to that one. Okay, so I hope that helps a bit. Not quite as long of an explanation this time as before, but I think that now it should be a bit clearer, hopefully, how you go about starting these. So hopefully that helped a little bit. Let me know if you have any other questions, and I'll send you some examples of those as well.